All right, pre-calc students, again, thanks for coming on board today. I know it's voluntary and it's not something you had to do, but obviously it's something you feel is important. You want to get a little bit ahead, or you just like the idea of studying math, which obviously I do too. Day 5, day 4 yesterday, we talked about normal lines and tangent lines. Today, we're going to talk about relative extremes and increasing and decreasing functions. Increasing means the function is going up from left to right. Decreasing means it's going down from left to right. Okay, I got some notes that I filled in ahead of time so you can stop and pause and record them. Just make the video be a little bit quicker. New term right here, a critical number. A critical number is when f prime of x equals 0, then x is a critical number, which means it's a possible rel max or rel min. Because again, if f prime is the slope of the tangent line, a slope that is 0 horizontal might occur right there, or it might occur right there. That would be the rel min, that would be the rel max. So that critical number idea is how we find possible rel maxes and mins. What happens at relative extrema? The function changes from increasing to decreasing. So that's the next part we're going to talk about right now, which is finding intervals for increasing and decreasing on a function. It's a multi-step process. Find f prime and all the critical numbers. Okay. Create an f prime plus minus line. Partition the plus minus line using critical numbers. Plug in values into f prime for all the intervals. Any interval that has a plus means it's increasing. Any interval that has a negative means it's decreasing. Let's put this into action on this example right here. So step 1, let's find f prime using that power rule. Derivative of 2x squared is 4x, derivative of 3x is 3, derivative of 4 is 0. So now we're going to evaluate the critical number, which means we're going to set that f prime equal to 0 and solve. I can do that pretty quickly. Subtract 3, divide by 4. So x is negative 3/4. That's the partition on my plus minus line. So I have two sides. I have left of negative 3/4. I have right of negative 3/4. And this is an f prime plus minus line. So what's a number to the left of negative 3/4? I'm going to pick f prime of negative 2. And then to the right of 3/4, I'm going to pick f prime of 0. When I plug negative 2 into f prime, again, I'm going slow. You could go a lot quicker. Negative 2 times 4 is negative 8 plus 3 is negative 5. So that interval is negative. F prime of 0 is 4 times 0. Again, I'm going slow. Plus 3 equals 3, which is positive. So what does that tell me? This function is increasing from negative 3/4 to infinity, and it's decreasing from negative infinity to negative 3/4. It's not increasing nor decreasing at the critical number. It's actually stopped. The slope is 0. All right, so that is finding intervals increasing and decreasing. Let's move on to another concept that we can use. Finding extrema on a closed interval. All right, we really have 3 choices when we're looking at a curve, a line, anything. If we're looking at the highest and low points of that interval, we could have something that looks like this. Out of those 3 points, where I started, here, and here, I would say this one is the highest, and this one is the lowest. Another example would be sort of backwards, like this. This would be the highest. This would be the lowest. And then the third case would be, let's see, the point we ended at was highest first, the point we started at was highest second, and what if we drew it like this? This point in the middle somewhere is max. This point is min. But what is that point? That is a relative extrema. That is a critical number. So what we really learned, and you could draw these forever, your highest and lowest point in an interval occurs at one of three places. Either the place you started looking at, the place you ended looking at, or any critical numbers in the middle. Okay? And there could be more than one critical. There could be more than one bump, more than one relative extrema. All right, so let's put that all together in this idea called finding extrema on a closed interval from A to B. First of all, find f prime. We know how to do that. Find critical numbers. We just learned how to do that. Set the derivative equal to 0. Evaluate the endpoints A and B in the function as well as any critical numbers. Okay? And we're going to go into the original function because we want to find the y values. Notice this is evaluated f of x, not f prime. Whatever the largest value is the max. Whatever the smallest is the min. All right, let's put this into action. Let's do one. Let's extend the screen a little bit more. All right, so what do we got to do? We got to locate critical numbers, which means we got to find f prime. Good old power rule. I would not want to be using a limit definition of derivative all the time, would we? Take a long time. 12x cubed minus 12x squared. Okay? So now we got to set that equal to 0 to find criticals. How are we going to solve this? Well, we got a huge GCF, 12x squared, which leaves us with x minus 1. Tee it up. One critical is 0. The other critical is 1. Okay? So now, you got to test to see if both of these criticals are in the interval from -1 to 2. Is 0 in the middle? Check. Is 1 in the middle? Check. So that means we got to test all four values into the original function. F of -1. Let's do that real quick. -1 to the fourth is 1 times 3 is 3. -1 cubed is -1 times -4 is 4. 3 plus 4 is 7. Let's go in order. The next value would be 0. 0 is just 0. That's pretty easy. F of +1. There's one end. I'm sorry. There's the other critical number. We already did an end point. We already did one critical. 3 minus 4 is -1. And F of 2. 2 to the 4th times 3 minus 2 cubed times 4 is 16. All right. So in that interval from -1 to 2 of this function, the highest point the max is at 2, 16. It never goes higher than that in that interval. And the lowest point is at 1, -1. It never goes below -1 in that interval. All right? So that is finding the maximum on a closed interval using the endpoints and any critical numbers. Let's do one more example. All right, so we got f of x equals x cubed minus 3x squared minus 9x plus 4. The interval we're looking at is from 0 to 5. I'm going to first find the criticals from the derivative. 3x squared minus 6x minus 9. I'm going to set that equal to 0. Pull the 3 out. We're good. We can do a couple steps at once. Leaves me with that. That's very factorable. X minus 3, x plus 1. If I tee it up, 3 is not a root. There's no x there. X equals 3. X equals -1. So again, we have two critical numbers. But this time, since our interval is 0 to 5, -1 is not in the interval. So we're not going to test it. But what we are going to do is we're going to test f of 0, f of 3, and f of 5. the endpoints as well as any critical number in the interval. 0 cubed, 0, 0, 0, 4. 3 cubed minus 3 times 3 squared minus 9 times 3 plus 4 is negative 23, pardon me. And then f of 5 cubed minus is 9. So what does that tell me? On the interval from 0 to 5, the max value is the 0.59. It never gets higher than 5.9. And the min value is 3, negative 23. In that interval from 0 to 5, it never gets lower than 3, negative 23. All right, I think we're doing great with this max and min intervals. Let's now do the first derivative test. Again, notes filled out ahead of time. First derivative test for rel maxes and rel mins. How can we find a max or a min using the first derivative? Here's how. Find the critical numbers, create a plus minus line for f prime, sounds familiar. If it's increasing followed by decreasing on the plus minus line, so if it looks like this, that means it's a rel max. That makes sense because, and we'll do this, increasing, decreasing, there's your max. On the other hand, if it's decreasing followed by increasing, then obviously the critical number is a rel min. All right, let's do one, maybe two. We got about 4 minutes. Find the critical numbers. Got it. Create a plus minus line, intervals increasing, decreasing, coordinates of all relative extrema, and sketch the curve. Yeah, we'll do a quadratic one. That's good. All right, let's go quick. F prime of x equals 6x plus 3. Set it equal to 0. X equals negative a half. I'll go fast. You guys can always slow it down and rewatch it. There's your f prime plus minus line. I label it f prime. Now if I plug in negative 2, I get into f prime, remember, a negative number. F prime of 0, I get a positive number. What does that tell me? Decreasing followed by increasing, which means, whoops, sorry, meant to do this, which means, darn it, which means it is decreasing from negative infinity to negative a half, and it is increasing from negative a half to positive infinity. I plugged the value in already, and I got f original of negative 1/2 equals negative 5. So that means negative 1/2 comma negative 5 is a relative min, decreasing followed by increasing. If I wanted to sketch it, I could. There's my decreasing, there's my rel min, vertex in this case, and increasing. All right, we can maybe get started on one, or, yeah, okay, x cubed. Here we go. All right, let's go quickly. We got about a minute. F prime of x equals 3x squared minus 12x. Set it equal to 0 to find criticals. Pull the 3x out. X minus 4. What are our two criticals? 0 and 4. Put them on our plus minus line. Plug them into f prime. I'm going to go f prime of negative 1, f prime of 2, and f prime of 5. When I plug those in real quick, I get plus minus plus, which means increasing, decreasing, increasing. So you could finish that off by finding the increasing and decreasing intervals. How do I find the coordinates for the rel min and max? I got to plug into the original. 0, 0 is the rel max, increasing followed by decreasing. and 4, negative 32 is the rel min.